Sorry, ma'am, I'm late.
Hi, Abraham. It's okay, no problem. We have just begun and we are going to learn about parallel and non-parallel lines. Okay, so like I have explained this topic before, but I want to go through it again. Okay, and we will learn about perpendicular. Do you know what is a perpendicular?
Yeah.
Ma'am, lines that will never meet again. Like these two, if they continue forever and ever, they will never meet again.
No,
This is parallel.
perpendicular intersects. Parallel never meets.
Yes, parallel never meet. So, if I say about parallel lines, parallel lines, I can say that there is a perpendicular distance between them, okay, which always remains the same. That there is a perpendicular distance between two parallel lines, which is always the same. That is why they do not intersect ever. Okay, they do not cut each other.
Ma'am,
All right. Yes,
ma'am, they're equidistant.
they are equidistant. Yes, we can say that they are equidistant.
At any point.
Yes, at any point of time. Always remains the same. And they do not intersect. Okay, so we will see an example. We will see an example. Suppose I'm having two lines here. Let's name them L1 and L2.
Isn't that actually kind of perpendicular? It looks different.
Ma'am,
Yes,
ma'am, it's not perpendicular, ma'am. Ma'am, because perpendicular lines will only meet at 90 degrees, ma'am.
yes, perpendicular distance, I mean to say. Now, what is
I
perpendicular
mean, isn't
distance?
this intersecting?
No,
Not
Simeon,
perpendicular.
no, not intersecting. Okay, they are parallel. And what is perpendicular distance? I'm drawing a line in red. Okay, I have drawn a line in red. So this distance which is between them, okay, this distance which is between them is known as the perpendicular distance. Okay, which I have made in red. This remains the same no matter how much we extend both the lines. Okay, this perpendicular distance, the line in red that I have marked is the perpendicular distance. Okay, this will remain the same. All right, so parallel lines can be like this, or parallel lines can be like this also. 1 minute. It can be vertical, can be horizontal, parallel lines. Okay, can be in this way as well. These are also parallel lines. They will never cut each other. Okay, when you remember cut each other, you can name them M1 and M2. Okay. Hope the perpendicular distance part is clear. Okay.
Yes, ma'am. Done.
All right. So I am going to erase this. And we are going to see the next, which is non-parallel lines. Okay. We are going to see non-parallel lines. Now, they intersect. Non-parallel lines are basically two lines which will intersect at some point. Okay. They are either intersecting
Even in the
already.
future.
Yes, even in the future. Either they are intersecting already or in the future they will intersect. When you will extend both of them, they are going to intersect. Okay. Those are non-parallel lines. Now, for example, I have one line, okay, and I have another line which is cutting it. Let us name them L1 and this is L2. They are cutting each other at O point. O point, okay. So they are non-parallel lines. Now, in this, the perpendicular distance, if I talk about, I am going to make it with red. 1 minute. Yeah. We can see that it has different perpendicular distance. Okay. Somewhere the perpendicular distance is small, then it is becoming bigger and then bigger. Okay. Means that perpendicular distance is not same. Okay. In non-parallel lines, it is not same. Somewhere it is small, somewhere it is a bigger distance. So it is not same in perpendicular, non-parallel line. Okay. Or non-parallel lines can be like this also. It can be made like this also. You have one line here and another line here. Okay, so they are cutting each other right now? No, they are not cutting each other right now. But if you will extend it, they will cut each other. Okay, so they are also non-parallel lines. Non-parallel lines, so you can name them M1 and 2. Okay, and perpendicular distance in this one. 1 minute.
Ma'am, it's
Yeah.
not the same, ma'am.
It's not the same. Here it is more, and if it will cut here, it will become lesser. Okay, so perpendicular distance in this one is also not same. All right, that are so these are non-parallel lines. Okay. Any doubt in this part? Okay. Done? Done, guys?
Yes, ma'am.
Okay. So next we will see transversal lines. Okay. Yes.
Ma'am, transversal is a line that cuts both the parallel lines.
Yes, they cut parallel lines or non-parallel lines. Okay. Basically, a line which is cutting two lines at different points, then that line is known as transversal. Okay, we will see how a transversal is made. See the diagram. Let's write the meaning first. If a line intersects two or more than two lines, at different points, then it is called a transversal.
So if a intersecting line intersects to like a pair of parallel lines, then it's like a transversal
Yes,
line.
Samir, yes. Yes, that is right. Okay.
But then what do you mean by different points?
I'll show you what do we mean by different points. Okay. Now these lines not necessarily need to be parallel, but sometimes they also a line is cutting through two non-parallel lines as well. Two non-parallel lines as well. Okay. How? We'll make the diagram and see. Okay. So these are two non-parallel lines. Okay. And this is one line that is cutting through both of them. One line that is cutting through both of them. Let's name them all. This is line L1. This is L2. Okay. And the transversal is PQ. PQ. And can you see it is cutting at different points means line L1, PQ is cutting L1 at this point, which we will name R point. Okay. And PQ is cutting L2 at this point, which we will name S point. S. Okay. So what is my transversal in this? PQ is my transversal, which is cutting line L1 at R point and L2 line at S point. Okay, that is why we wrote that at different points. Okay.
So like the points are not directly above each other.
Yes, they are not directly above each other. It's where the line meets the transversal, where that point is. Okay. Now parallel lines also we will make and see.
So it's like this is wrong.
Like this, it's drawn. Is this parallel line, Samir?
I didn't exactly draw it with a ruler, so it's not exactly a parallel line.
But kind of. Yes, Samir, it is like that.
So this is correct or
Yes,
wrong?
it is correct. It is correct. Okay. Just that it's too small and lines are very
Ma'am,
close. else the diagram is correct. Yes, yours is also correct. Abraham's is also right. Yes, Abraham, yours is also right. Okay. So these are two parallel lines and a transversal is cutting. You can draw it straight through cutting through both of them, or you can draw it slant like this. Okay.
Ma'am,
So this is
question, ma'am.
yes, Abraham. Yes.
When it's transversal the line, when it's getting cut, ma'am, can I say point R is equal to point S in the second figure?
Can I say that point R equals to point S in the second figure? This
Say,
one, where
yes.
where the lines are parallel.
Yes, ma'am.
Okay. So basically, Abraham, when we have parallel lines and a
Wait, wait.
transversal through them,
Ma'am, sorry, not that. Can I see the place below R is equal to point the place where S is? The place below R is equal to the place where S is.
below R means
Like,
this
yes,
place
yes, ma'am. Because of corresponding angles.
because of corresponding angles. Yes, we will study about corresponding angles. Okay. And corresponding angles, when lines are parallel, we have corresponding angles which are equal to each other. Okay. But when lines are not parallel, in the first figure, lines are not parallel. So it will make corresponding angle, but their measure will not be equal. Okay. I'm going to teach you that what are corresponding angles, how are they made, when are they equal, when are they unequal. Okay. We will do all of that. Okay. Right after this, I will show you what are corresponding angles and how they are made. Okay. Now, what I was saying, yeah. So this is parallel. Also, what can happen? What more can happen? It can
Ma'am,
also be three lines. Yes,
ma'am can also be 3 lines, 4 lines, 5 lines, ma'am.
three lines, four lines, five
Ma'am,
lines.
see,
Yes,
ma'am,
yes, say.
ma'am, the equal sign is parallel lines,
The equal sign is parallel lines. Yes, the equal
and
sign is parallel lines.
and and the not equal sign there is a transversal.
That is a transversal. Okay, that is right. Yeah. Okay, so I have made three lines now. Okay, M1, M2, M3. Okay, so there can be like more lines as well, but the line which is cutting through them is known as the transversal. Okay, and that is known as transversal. But basically, what do we have in our course is up to two lines. Okay, like a transversal cutting up to two lines. It can be two parallel or two non-parallel lines. Yes,
But it
Ma'am,
could
so there
also
is
be like three or more.
three or more. Like I was going through the chapter, and I don't think there is four or five lines till that we don't have. We mostly have till two lines.
And a transversal line could also be like there are three parallel lines, like three pairs of parallel lines, which is 6 lines, and then two lines
Mhm.
cutting them.
And then two lines cutting them like
Yeah,
this.
yes, like that.
Yes,
ma'am,
that can
is
be two.
this chapter 11?
This is chapter 11. Yes, this is chapter 11 going on. There can be two transversals in it, but again, we don't have that in our course. Okay, this will probably be coming in the higher levels. Okay, we don't have that thing in our course. We have till one transversal we have, and the angle they are forming that we are having. Okay. So one thing I will show you how angles are forming in between the transversals.
Ma'am?
Let's make a fresh diagram and we will see. Yes, Adri.
Okay. So make the two parallel lines and one line that will cut both. Make sure it cuts both, okay? Then only you can get the angles.
Yes, they cut both like this. Okay. Now, how do we have the angles? I will show you.
Ma'am?
Let's name them first.
Ma'am,
Yes,
see here? Ma'am, there are 8 angles formed.
8 angles formed. That is right. 8 angles are formed when two parallel lines are cut by transversal lines. We have 8 angles that are
I
formed.
didn't hear if you asked a question or not. I just went to get a box.
It's okay, Simeon. I didn't ask a question. I was saying that when two parallel lines are cut by transversal lines, 8 angles are formed. Okay, 8 angles are formed. One, two, three, four. Okay, four above. Then on the second line, we have 5, 6, 7, and 8. Okay, 8 angles will be there, are normally found. Okay, hope this part is clear.
Yes, ma'am.
Transversals. Okay. Now we will learn about
So every
Ma'am,
time one line is cutting another line, you form 4 angles. So if it was three lines that are being cut, it could be 3 into 4, that is 12 angles, right?
if 3 lines are being cut, it would have been 12 angles. Yes, and yes, 12 angles will be there. Okay. Now about corresponding angles, we will see.
can I say ma'am, what are corresponding angles?
Yes, Abraham.
Ma'am, first of all, ma'am, corresponding angles are in a. Ma'am, your screen is glitching a lot.
Now tell me, I was erasing that as well.
Ma'am, corresponding angle. So if I have an angle and the angle like over here, as you see I'm showing ma'am on my screen. If it makes like an F like shape, F, is from F shape. See, so
Mm-hmm.
the angle that is over here and the angle that is over here corresponds together. Now, and that F can be in any way.
Mm-hmm.
Also, ma'am, it can even be opposite, like the angle over here corresponds with and the angle over here corresponds with the angle over here.
Mm-hmm. Yes, that is right. Okay, so basically, they are the angles which are formed on the same side of the transversal. Okay, on the same side of the transversal. We will see how. Suppose I have, let's take a green color. Okay, I'm having this figure, suppose this same figure. Okay, and I'm having some angles. So what will be the corresponding angles? Look at one. Can you see angle one? This one, angle one. Okay. Now on its same side, right below, right on the next line, on the same side is which angle? Angle 5.
5.
This one. Okay. Right below it and on the same side. So angle 1 and 5 are corresponding angles.
Ma'am?
Now look at the other side. We have two. Yes, Abraham. Edric.
6th time you call me Abraham, ma'am.
Edric. Yes. Tell me.
Ma'am? Ma'am, corresponding angles are always equal, ma'am.
Yes. If they are parallel lines, they will be equal. If they are not parallel lines, okay, non-parallel lines, they will not be equal. So 1 and 5 is forming corresponding angle. Now see, look here, angle 2 is on this side,
Ma'am, angle
okay,
2 and 6.
and angle 6, okay, same side, 2 and 6 will be corresponding. Okay, then we have angle 3, okay, and angle 7, which are on the same side. Below, both are below and on the same side, so 3 and 7 are corresponding. Okay, and we are having angle 4 and angle 8, which are below on the same side, so 4 and 8 are corresponding. So these are corresponding angles. We'll write the definition. They are the angles which are formed on the same side of transversal. And of transversal. Transversal line when parallel lines are intersected by transversal. Okay. Line. I hope you know what is the symbol for parallel lines when we are denoting two parallel lines. Suppose SI,
Yeah,
S1
I
and
learned
S2.
it in one other book, but I kind of forgot. I think it's like two lines.
Yes. Two lines on.
Two lines. Yes, two lines. So suppose these two lines are parallel. So I can write S1, draw two lines, S2. Means S1 is parallel to S2. This is a symbol we use for parallel lines. Okay.
Why did you write the two small next to the S?
You can make it small also. Okay. When parallel lines are intersected by a transversal. Okay. Now two fresh diagrams I'm going to make showing both the cases where non-parallel lines, where corresponding angles are made in non-parallel lines and where corresponding angles are made in parallel lines. Okay.
Ma'am, I didn't quite understand this diagram you made. Could you re-explain it, please?
I'm going to re-explain
Tonight.
it and re-explain it. We'll make it again
Ma'am,
and
all
see.
the angles are corresponding.
All the angles are corresponding in parallel, yes. Pairs of angles are corresponding. Okay, let's first see when we have non-parallel lines. When we have non-parallel lines, I'm having a line here and I'm having a line here like this. Okay, and one line is cutting them. This is my transversal. This is my transversal. Okay, let's name them Q, T. L and M. Okay, now I explained that when two lines are there, eight angles will be formed. How many angles? Eight angles will be formed. Okay, so we can say that this angle, the first angle, okay, will be equal to which angle?
Ma'am, fifth angle.
Not equal, corresponding to
Fifth angle.
this angle. Okay. And let's name it 1 and 5. Okay. Now, next we have angle 2. That is this angle. This is angle 2. Will be corresponding to this
Angle
angle.
6.
Yes.
But are those lines actually parallel?
No,
No,
Sunil,
they're
this
not
is not
parallel.
parallel.
Not parallel.
They are not parallel. Okay, non-parallel lines, but corresponding angles will be formed, just that they will not be equal in measure. Okay, they'll
Like
still be called. Yes.
the corresponding angles are when non-parallel lines are intersected.
Corresponding angles will form if either of lines will intersect. If parallel lines be intersected by transversal, then also corresponding angles will be formed. If parallel lines will be intersected, non-parallel lines will be intersected with transversal, then also corresponding angles will be formed. But corresponding angles will be equal only when parallel lines are intersected by transversal. Okay. I will write it all and
Because
I'll.
I saw it like when parallel lines are intersected by transversal. You wrote over there.
Yes, parallel lines are intersected by a transversal. Corresponding angles are equal that time. Okay, so can you see it in green, Anaya? This is
Yes,
angle
ma'am.
3
Ma'am, 3.
and yes, 3. And
Ma'am,
this is
7.
angle
Ma'am,
7 at below. Okay, the same colors means those are corresponding angles. Okay, then this is angle 4.
ma'am, ma'am, 8.
And this is
I can't
angle
really see what you wrote.
8. You can zoom it a bit, Sunil. Zoom it in a bit. Okay. And now, so angle 1, let's use the colors.
Ma'am, so what is corresponding in them basically?
Corresponding angles means they are forming on the same side of the transversal. Okay, same side of the this is the transversal angle L. So basically, Anaya, angle L and angle M are both being cut by P and Q. Okay, so this part is the left side of line L and M, left side of the transversal. This is the right side of the transversal. Okay, this is the upper left of line L. Okay, of the transversal, like upper left side of the transversal on line L. Okay, and this is the upper left of line M. Upper left of line M. So upper left of line L and upper left of line M will be corresponding. Similarly, lower left, okay, angle 3 and 7. Can you see 3 and 7? 3 and 7 are lower left of the transversal. That is this part, this 3 and here. Lower left of line M and lower left of line L. Okay, so that is why 3 and 7 are corresponding. Similarly, on the right side of the transversal, that is this side, if you see, we have upper left, upper right
Right.
is 2 of
I think
line
I
L,
understood, ma'am. Thank you.
of M is 6. Okay, upper right is 2 and 6. So 2 and 6 are corresponding like
Ma'am,
that.
and
See,
then lower
so
right of L is 4 and lower right of M is 8.
M is 8. So angle 1 and angle 5. Okay, I'm writing you can put corresponding angles, put a dash, and you can write it. Then angle 2 and angle 6. Then we have angle 3 and angle 7
Angle
and
4 and angle 8.
angle 4 and angle 8. These are corresponding angles of non-parallel lines. You can
Ma'am,
write the one where you
ma'am,
have made this 1 minute, Edric, where you have made this diagram of non-parallel lines. Okay, on this particular diagram, write one line below it that when a transverse intersects two non-parallel lines, corresponding angles made by them are not equal in measure. Okay, I'm writing it. Then a transversal intersects two non-parallel lines. Non-parallel lines corresponding angles made by them angles made by them are not equal in measure. They are not equal in measure. Okay, written.
Yes, ma'am.
yes,
All
ma'am.
right. Okay.
Ma'am,
But what happens? Yes, Edric.
ma'am, time up.
Have you written it?
Yes, ma'am.
Okay. Focus on the writing, Edric. Now, Simeon, hope it's clear.
Yeah,
Okay.
I got
So
it.
tomorrow, you got it. Yes. Tomorrow, like today, we saw how corresponding angles are formed in non-parallel lines. Tomorrow, I will show you how corresponding angles are formed in parallel lines and how they will be equal. Okay. If they are made in parallel lines, they will be equal. Okay, non-parallel lines, then the measure will be unequal. But corresponding angles will be made in both the lines. When transversal is cutting parallel lines, then also corresponding angles will be made. Non-parallel lines, then also corresponding angles will be made. Okay, so we'll continue from here tomorrow and we will see how parallel lines work. We'll also see about alternate angles and interior angles. Okay, that also we will talk about. So that's all for the math class right now. Okay, and 5 minutes break and then we will start the science class. All right.
Okay, ma'am.
Okay. Okay. See you tomorrow.
Bye, ma'am.
Bye. Okay, hope you guys are there. Please turn on the videos. We are about to start. Abraham, video on, please. So today we are going to start the 14th chapter, that is magnets and electric current. Now, have you seen a magnet before? Yes. Okay. So when I was a kid, I used to play with magnets a lot. Have you seen the magnet that is this shape, like this kind of, okay, something like this. And we used to have a lot of them, and I used to play with it a lot as a kid. And we used to do some like weird things, experiments also with it. We're trying to pick different metal things with the magnets and all, right? So, yes, Abraham.
I had something. I had the same like oval shaped magnet. Just recently, I had found it in my nana's house. I was playing with it, but then my father had to take it away because it was too powerful. It could suck out our device's memory.
Yes, that magnet is too powerful. Yes, it's this magnetic power is very high. That magnet is very powerful. Oval shaped magnets are there. So now, magnets in steel shops, people also use it to check if the utensil is made up of full steel or not. Okay, like if the utensil is having iron mixed in it with steel, the magnet will stick in it on it, the utensil. Okay, because magnet attracts iron. Okay, so it is used to check it. Then magnets are used in a lot of things that we use daily, such as in almirah doors, fridge doors, wooden boxes and their handles and all. Okay, magnet is used, and these are helpful in closing them easily. Have you seen cupboard doors? When we push them slightly, they just like pause near the main frame and then like sticks to it. That magnetic kind of doors that closes like that. So in that, magnets are used. Okay, and they are also found in toys and speakers. Also, there is a deep relation between magnets and electric current. Magnets are also used in some electronic items. So we learn about magnets. That's made up of a magnet. Okay, yeah, you can see it sticking together. Yeah.
I think I saw a video of a guy who had the same kind of magnet and he was taking it and making different like models with it.
Yeah,
And then he covered that with clay and baked it.
Oh,
ma'am,
yes, Abraham.
these are called magnetic balls. So these are basically a toy where you can mold things. It's thing, but it sometimes just falls apart because of the repelling and attraction.
Because of the repelling and attraction. Yes,
These are not
magnetic
so
are.
powerful. These are not powerful.
Okay. Yeah, but they are fun.
One that I saw was very, very powerful. So you have to like take a wooden wedge and take a hammer and then separate it like that.
Yeah, there are some very powerful ones, but those are not the ones coated with color. Like that's why it's
Yes.
not powerful because they have a color coating.
Mm-hmm.
Like this guy had a very light magnet and it was super powerful also. He just let it go away. It went and crashed into his window somehow and broke the window.
Okay. Yes,
He got
Simeon,
I.
attracted to the
Simeon,
North Pole or something.
Simeon,
Okay.
Simeon. Did you check? Do you think he was setting up the frame like a frame like this instead of when he was recording? He put the frame like this and a fake window. So when the magnet ball crashed, it broke it just for editing purposes, just for fun purposes.
I don't think so.
Okay.
Because
So
otherwise,
the
the video was showing him also standing at the same time. So it would have to be like him standing on the side of the wall.
That's
mhm.
possible.
Yeah, so yeah, that is right. Some magnets are very powerful, very powerful. Some magnets are less powerful. Okay. Yeah. Now it attracts
And
things
that trains
that
that
are
even run on magnets. That trains
which
that
are
float and run on magnets. Magnets.
trains.
Yes, ma'am. Trains.
Yes, yes, that is right. Now, magnet, what does it attract? It attracts things made up of iron. Also, it attracts metals such as nickel and copper. Okay. Now, the items that gets attracted towards magnets are known as magnetic items. Okay, they get attracted towards magnets. They are known as magnetic items. Those which do not get attracted towards the magnet are called non-magnetic items. Okay, then there are many mountains in nature having magnetic properties. They are known as natural magnets. It is said that a place named Magnesia was in eastern Greece country around 2800 years back. One person was grazing his sheep in the mountains. He had a stick with iron cap on the top. This cap attracted mountain. He took some pieces of rock with him and concluded that they attracted iron. Discovered that if these pieces are freely moved, then they stop in one direction. This was known as lodestone, meaning mountain telling direction. Mountain telling direction. This rock was made up of minerals known as magnetite, hence the name magnet.
I read the same story in one history book, but it was slightly different. So it was a shepherd boy, and he was doing the same thing, but he had an iron nail in his hand, and the nail went through his foot and stuck to one rock, and then some other people had to come and help him get it out, and he
Oh,
thought the rock was some kind of god.
okay. So basically, it's just the rock that is, or the mountain that are having magnetic properties, due to which that the this thing metals are getting attracted to it. Okay, and so this is known as lodestone, meaning mountain telling direction. Like if the pieces of rocks really move, then they will stop in one direction. This is they called it as lodestone. Okay, then this is an activity. Get a magnet from nearby area. You can also get magnet from an old sticker or toy. Prepare a list of items from your environment having magnetic and non-magnetic properties. Observe them in the following table. So you can like use a magnet and then test it with various things, which what is getting attracted and what's not getting attracted. You can write the names of it. Okay, you can write if it is magnetic or non-magnetic. I remember when my brother was young, and even myself, I used to do it less than my brother used to do it more. He still does. When some like electronics in our home, when they are stopped working completely, like they get very old and like right before we are about to throw them, he just takes them, opens them up, takes out the magnets, and then plays with it. Like he likes to play with magnets.
I
He
used to
likes,
collect magnets, but then I had to throw it away because my brother was going to swallow them,
yes,
like my
brother was
baby
going.
brother.
Yes, yes. So he also used to like collect magnets, take them out from like my headphones and things that were like stopped working, like mainly electronics and all. So speakers also. when they were too old, stopped working, before throwing them, he opened them up all together, took out all the magnets and things like small circuit kind of things are also there in the electronics. Green circuit kind of thing, small board, green color board, small board. So that also he used to play with. So yes, the things have magnets in them. Okay, and we can test if something is magnetic or not, seeing that if it is attracting to the magnet or not. Okay, then we have different shapes and sizes. Yes, Anil.
I used to do a similar thing also, but I used to like take anything that's not working and dismantle the whole thing and then try to put it back again.
Try to put it back again. Yes, kids do that
Ma'am,
all the time. Like they dismantle
ma'am,
things and yes, Abraham.
when I was, when I sometimes do when there's a broken appliance, I take it. So when I was small, my father used to help me take it apart and take all the motors, the magnets, and all like the the parts that move and some gears even, and then collect it in a box. And then when my remote control cars would break, I would open them up, take out the stuff. Or like if the bumper is broken, I would still open it up and take out the stuff. And then once I get once with my building blocks, I put a remote control circuit that I had taken from a car and I spun something using it.
Then you did what? What did you say at the end?
Then, we were taking apart stuff, and when we took apart a remote control car, we found its circuit was still working. So then, out of that car, me and my friend made something that actually works with the remote.
That
We
actually
just made
works with the
something
remote.
spin,
Okay, that is nice.
and then
That's
out of a
cool.
ma'am, those disc soccer balls we get out of that, we made a colorful Christmas display.
Okay, that's nice. All right. So yes, we can put those things to use. So what my brother did, this is about yesterday night. So we bought big chips packets, both of us. Okay. And like he was having two magnets that he took out from somewhere. Two magnets, so two pieces, like round magnets. This kind of magnet. The first diagram, can you see ring magnets? So it was like this in the shape. And we both brought big chips packets. So he ate half of it and then like folded the pack like this, and then one side you put the one magnet and the other side you put the other magnet and then stored it. So my mother like saw it while like taking something from the cupboard. She saw and she said, "See how such a ninja technique he has used to pack the chips." So he laughed so much. He said like he's using this ninja technique to pack the chips with magnet like that,
What
seal them.
technique?
Smart.
Ninja technique.
Ninja.
Yes.
Ma'am, the
Yeah.
problem with that is if the magnet falls in his chips and he mistakenly eats it, I
No,
mean
that
that's
was
going
It
to
was
big.
too
suffer.
big for that.
It was big. It was too big for that. And also the chips packet was like sealed, na? So it couldn't get inside. If it falls, it will fall outside only, not inside the packet because it was like twisted and then they were put together by the magnet. And then, so we have types of magnets, and this is known as the circular magnet or ring magnet. Okay, and these are the bar magnet, ring magnet, and the last one is known as horseshoe magnet. Horseshoe
Because
magnet.
it's shaped like a horseshoe.
Yes, because it's shaped like a horseshoe. Magnet is found in many shapes like circular, bar magnet, horseshoe magnet, etc. There are two poles of every magnet, North Pole and South Pole. The magnetic power of magnets are stored on these two poles. North Pole is symbolized with N and South Pole is symbolized with S. Yes, Abraham.
Ma'am, when there's a North Pole and the South Pole, ma'am, if you drop a magnet, they split apart. So, ma'am, then the North Pole interchanges and the South Pole interchanges, right? So, like, it will have its own North and South Pole, and the two magnets won't stick together.
Yes, it will have its own North Pole and South Pole. If it splits apart, it will have that split apart piece that will be there, will have its own North Pole and South Pole. Okay. And this we used to do as like when we were kids, take a bar magnet, put some iron powder on a clean paper, keep the magnet above it. You'll find maximum iron powder sticks on the corners of magnet. There are no traces. There are no iron traces on the center of magnet. Okay, it sticks
I
in the yes, Sunil.
I also did this and then I dropped the magnet. So the magnet broke in half. So then I took the south pole side and glued it to the other side and I was holding it together until it dried. And then I finally let go and after for a long time it stayed like that and then it just shot apart.
Mm-hmm. Yes. So basically the magnetic power is on the ends of the magnet. Okay. On the poles that are north pole and south pole, the end points of the magnet, there is where the most magnetic part is stored. Okay. Then 4.1 you can try out.
Ma'am, we had this activity in our school where we had to take a magnetic bar because they're in our book. So then you put paper clips on each of the places and you could stick the most paper clips on the end, but when you enter the middle, not much could be stuck.
Okay. When you reach to the
Abraham,
middle,
go to
not much.
school.
I went and I,
You used to go before joining NIOS, right?
yes, ma'am, before.
I didn't hear the last part.
You didn't hear the last part. So basically, they did an activity where they took the magnet and they started attaching paper clips from the side, okay, to the magnet. When they went reached the middle, they were not like the paper clips were the attraction, the magnetic attraction was not as strong as it was on the sides in the middle. Why? Because on the sides, the magnetic force is most strong on the North Pole and South Pole. The side in middle, it is less stronger. The magnetic force is less stronger. Okay, then we have the reaction of magnetic poles. When we bring together two magnetic poles, what happens? Okay, the same poles of a magnet repel each other and different poles get attracted to each other. If I bring the south pole and south pole of a magnet together, okay, if I'm trying to bring, see in this diagram, it's trying to bring together south pole and south pole of a magnet, it will repel and they will try to push each other away. Okay, they will try to push apart like this. But if opposite poles are brought together, like South Pole and North Pole, or North Pole and South Pole, like this, then they will try to attract each other and they will like get stuck. Okay, they will attract to each other. So this is the reaction of magnetic poles, like opposite poles repel, sorry, attract, opposite poles attract, and same poles will repel. If it is south and south, they will repel. If it's north and north, then also they will repel. Okay. When magnet moves independently, it stops in one direction. The pole pointing the north direction is north pole. The pole pointing south direction is south pole. This property makes magnet usable in a compass. Hope you all know that magnet is used in a compass.
Yeah, I made an
Yeah, the north needle is
activity where
the
I made this.
You made this. Okay, yeah. So now if the needle is pointing to the north direction. Okay, it is North Pole, it's the north direction. South direction, if it is pointing in, it's the South Pole. By compass, we mean a round dial having showing many signs. Magnetic needle is in the center, that is used to point directions, and it is always pointing north direction. We know our distance from north south direction. Okay. Compass is used in aeroplane ships and forest offices to know the correct direction. To know the correct direction. Magnets are also used to select iron items from garbage dump. Magnets are used to carry heavy items of iron with the help of a crane. Okay, if you've seen a crane like this, metal is attached on it. Okay, the part which is
Isn't this
carrying the
used at the place where they recycle the car?
place where they recycle the car. Yes, it can be found at the places where they recycle the cars. That's right. Okay, and for 14.2 also you can try out. Okay, 14.2 also. Please try out. Can you all tell me any more uses of magnet besides the ones that we studied about? One use.
Ma'am, can I say?
Yes, Abraham.
Ma'am, I had said we can use magnets for trains. Then also
Mm-hmm.
we can use magnets in our computers and laptops when we have the speakers. We use magnets over there. In motors, we use a certain type of magnet called electromagnet. When electricity passes, that makes the motor spin. Then, ma'am,
Mm-hmm.
and when we want the magnetic force to attract, when we may, like, ma'am, almost in every electronic device, there is some type of magnet. Like if you have this certain type of device that has a magnet charging thing, that the charger which sticks to the back like a watch, that also has magnets. Some chargers even
Mm-hmm.
use magnets. Like a phone has a magnet, like it's called a MagSafe for Apple devices. I don't know what's called for other ones. When it sticks to the back, it charges it automatically.
Okay. Good, Abraham. Yes, Onion.
Also that you could use it for things like your brother did. You could seal bags with it, or else like if you could take a really strong magnet, then you could take like a rope or something and then seal things with it. Like not that like in all these movies they will come like an electromagnetic current and then they will tie the prisoner up with that and the prisoner cannot get out at all.
Okay, I got it. That is like electromagnetic current that is surrounding the prisoner. Prisoner is in between. Okay, and if he gets out, he'll get a shock. That kind of thing.
Yeah, like that.
And also,
Yeah.
mom, magnets can be used to decorate your fridge and all that. Like, my mom has a lot of magnets that are like colorful magnets or something like that. Like wooden pieces that have magnets attached to them at the back, and then they're
Mm-hmm.
like on her fridge. So, decorative items she uses.
Yes, fridge
My
magnets.
brother has my baby brother has numbers with plastic numbers with magnets at the back. He puts it
Magnets.
on the fridge and plays with it.
Yes, sure. We have the fridge magnets that we can use. Different kind of things with like small circular black color magnets stuck at the back of it, with which you can stick them on things. Yes, Abraham, saying something. Good, Anaya Sunyan.
Man, we can even use magnets, ma'am, if we are like, if we want to connect two things, if you have a wire, ma'am, and like
Mm-hmm.
we can use magnets to experiment for Smith sorting. So if we have a solution that has iron, iron fillings inside it and water, to separate it instead of evaporating the water, we can just take a magnet and let all the iron fillings stick to it.
All the iron fillings stick to it. Yes, that is
I
right.
also saw once a video where this guy created a way to close the hatch at the top of his ceiling. So there was like I don't know what it was, something that blocked the magnetic current between the two powerful magnets. One was on the hatch and one was on the frame. And then he had a string tied to it, and when he pulled very hard, he didn't have to go up and close the thing. He just pulled the string very hard, and that thing came out from between of them, and both the magnets attracted and the hatch closed.
Ma'am,
Okay.
could this
Yes.
string be connected to a switch and the switch be running opposite? So they are both electromagnets. And when he pulls it hard, the switch flips, thus attracting it. And maybe if he pulls another string, the switch will flip again, thus repelling it. So he doesn't need to go up and open it.
Okay. So a switch was repelling so that it will open again. And if the switch is
Yeah,
flipped,
like a
then it will cause
switch
attraction.
that can like turn the one magnet around so it repels. And
I get it.
also you could switch
Yes.
it from below and then it turns the magnet around again so it attracts.
Okay. Yes. That saves you a lot of work and smart idea of using magnets to close and open a hatch. Can you see this pen of mine? Even this
Yes, ma'am.
has the cap is magnetic, so when I put it and leave it, it will close on its own. And on the back also, if I'm putting it, like it's attracted. 1 minute.
Ma'am, my sister has a certain type of pen which she can
Mm-hmm.
disable. Like, so it comes in a kit where there are balls, and then there's a pen. So she can break the pen apart into board because it all has magnets, and then she can make stuff like put them together and make stuff.
Put them together and make stuff. Yes, that is right. Yes, and I'm. Yeah. So there are like things, magnetic things that you can break apart and put them all together because magnets are there, so they will be joined together. There
Ma'am,
are
you,
things, good examples.
ma'am, you can also make a toy like that has iron fillings inside, and when you put the like and you put it in a jar, when you put the magnet all around, the iron fillings will stick, making cool shapes.
Eyes will start making shapes.
No, the iron fillings.
Iron fillings. Iron fillings will start making shapes. Yes.
Yes, ma'am.
We used to, yeah. So that oval magnets that we used to have, I used to have 4, 5 of them. And like suppose I have like the magnet I placed it, the one oval magnet I used to take and then do it like this over that magnet, like this. Okay. And then that magnet used to spin. Like when it was laid on the surface, it used to spin when I
Was it
used
a
to
strong magnet?
it was a strong magnet. Yes, oval
Okay.
magnets are very strong and it used to spin. Also, if there is a thin surface, this also we used to do. Yes, like Abraham is doing. Okay, yes, we can see it spinning, moving, and that is right, Abraham. That magnet used to turn around very quick and spin the whole thing. Also, we used to put one magnet on the table, like thin surface table, one magnet below the table. Okay, like right below that magnet, which is on the top. They used to move the below one, so the top one used to move on its own due to that strong force of attraction. That also we used to do.
Ma'am,
It is a very strong magnet.
I once
Yes.
saw an ad where where somebody was trying to get a knife, and then but the person was taking a magnet and then pulling the knife away from the person. So every time the person tried to take the knife kept going fast from it.
The knife was going far from it because it was pulling
Because the
due to the
person under
magnet.
the table was pulling it towards him.
Yes. So that also magnets do. And okay, electric current we have. Next topic, we have electric current. And we are going to start electric current tomorrow. Okay, homework for today. Please try out 14.1 and 2 exercises. Okay, and electric current we will start tomorrow. Math test is also there tomorrow. Okay, chapter 9, please prepare. All right, then I'll see you guys tomorrow. Bye.